Shall we start the class? Am I audible?
Yes, ma'am, you are audible and screen is also visible. We are 10 of us now, as you may say, ma'am.
Yeah. We will start now. Others can see the recordings if they need it. So in today's class, what we will do is that we will see what is randomness, and also we will see some basic concepts in statistics and probability, because these are the fundamentals for machine learning. So we will touch upon the fundamentals, and as we go, we will pick up what is there in the machine learning. So when I say randomness, we will see how to represent randomness in an algorithm. And also we will see some of the fundamental ideas in statistics. In the last class, I told that machine learning will the relationship between the feature and the label. So it is understanding the relationship among the data without needing to talk about each piece of data individually. So we would like to know if our data is there, we would like to know if all the samples are in the same value, or is there any differences between the data, or if any piece of data doesn't seem to fit, or is there any pattern among the data. We would like to see all those things. Why? Because when we know the data more, we can best select the design and the tools for manipulating the data. It is just like an analogy. Suppose you have two wooden frames and you have a small metal to connect these two wooden frames. If this metal is a screw, we need a screwdriver. If this metal is a nail, we need a hammer to connect the two bolts. So when we know about the data more, we can best choose the tools for getting most of the data. So we need to understand basic statistics of the data. It is very essential in selecting the right tools and algorithms for learning that data. Next, we will understand what is so the main point from here is that we need to know the data. Knowing the data is the first rule in machine learning. We will see what is a random variable. We are talking about randomness. So let's understand what is meant by random variable. Random variable is a variable that represents the outcome of a random process or an experiment. We have a random process or an experiment. The outcome of the experiment is represented by the random variable. So there are two types of random variable. One is discrete random variable and the other one is continuous random variable. Discrete random variable takes on countable number of distinct values. So suppose tossing a coin has two outcomes, head and tail. It has countable number of distinct values. So it comes under discrete random variable. So the continuous random variable example can be, it can take infinite number of values. For example, height of a person. It can take infinite number of values within that particular range. For height can be 150, 120.55, 160.77. It can take infinite number of values within a particular range. So it is called as continuous random variable. Is it clear? Random variable is nothing but it has two types. One is discrete random variable, other one is continuous random variable. Discrete random variable means it takes countable number of distinct values. In continuous random variable takes infinite number of values within a range. So these are the two different types. We will be seeing most of our examples will be in discrete because we are using computers. Most of the data will fill in discrete random variable. Some data will be in continuous random variable. So let us understand some basic statistics. What is called as mean? So mean is usually referring to the average. Suppose you have a numbers, for example. Mean of these numbers can be written as a sum of all the entries divided by the number of entries in the list. So this is called as mean. What is a mode? Mode is the most frequently occurring number. The most frequently occurring number here is 4. So mode is the most frequently occurring number in the list. What is a median? Median is the middle number in the list. Middle number here is 4. Suppose if you have even number of entries in the list, it could be the mean of the two-centered value will be your median. So these are all for refreshing our basic concepts. So now let us understand what is probability distribution function. So let us imagine we have let us imagine in the junkyard we have 5 different types of cars. So the y-axis tells us how many number of cars are present in each type, and the available cars are sedan, pickup, minivan, SUV, and wagon. If you look at it, we have total of 9. Assume that we have total of 950 cars. So we have more minivans compared to pickup, sedan, wagon. Next to minivan, we have more number of pickup cars. Now, if you have to pick up one car in a lot, so how likely we can pick up a minivan in a lot? For that question, we can get an answer saying that we have to divide the height of each bar divided by the total number of cars. So how many cars of that type are present relative to the total number of cars in the yard? So the probability can be given as how many number of cars in a particular type divided by the total number of cars will give you the probability saying how likely a event can happen, how likely when we pick up it is going to be a minivan. It is called as the probability. So I can draw the probability distribution like this. This is for sedan, pickup, minivan, SUV, wagon. So the probability of choosing a particular type of cars is given in the y-axis, whereas the x-axis shows the type of the car. So what we have done here is that we have divided the height of the cars divided by the total number of cars, and to get our probability distribution. If you want to get in percentage, we need to multiply this with 100, then we can get a percentage. So since this is a probability, the summation of all these car types, probability distribution of all these car types should come to 1. If it is not summing to 1, then we cannot call this as a probability. So by dividing it by the total number of cars, we are normalizing the distribution. So we now know what is a probability distribution. So probability distribution can be considered as a function. What is a function? A function will have an input and an output. Suppose y is equal to f of x. X is your input. F is a function which is operating on the input, and y is your output. So probability distribution can be considered as a function. So here our input is the type of the car. Our output Y is probability of getting and our function is the probability distribution. So since we are seeing at the getting a probability of a particular type of car, this is nothing but a discrete probability distribution. Otherwise, we can call it as probability mass function or PMF. Imagine if the values, outcome values are going to be real numbers or continuous numbers. So we can, for example, we can say instead of what type of car we are going to get, if we are looking at how much oil is left in each car in the junkyard, then the amount of oil is a continuous variable. So the probability distribution function will be something like that. It is not going to be discrete. It is going to be a continuous value. A continuous value like this. So the amount of oil can be written instead of the type of the car, the amount of oil in each car is written in the x-axis, and the y-axis will give the probability of selecting a car with a particular type of oil, like with a particular quantity of oil. So this distribution is again a probability distribution, but it is called as a continuous probability distribution. Is it clear? Is the discrete probability distribution and continuous probability distribution is clear? Probability distribution is a function. Any function will have an input and an output. Function is an operator which is operating on the input. From our car example, our input is the type of the car and the output is the probability of getting a particular type of a car. So in continuous, this is called as discrete probability distribution or probability mass function. We have another type of probability which is called as continuous probability distribution, which takes continuous values as input. Instead of the type of the car, if you have amount of the oil left in each car, the outcome of the probability is the outcome is the probability of getting a particular car with a particular quantity of oil could be the outcome. So if the input is going to be continuous, then the probability distribution is defined as continuous probability distribution. Otherwise, it is called as probability density function. Is it clear? So next, let us see, we have seen some randomness now. So let's see how this random variable is applied in computing. So let's understand about this random numbers. So usually when we mean random, what we are referring to? We are referring unpredictable. But computer programs are deterministic. We cannot have unpredictable things in computer programs. It is reproducible. So we cannot have random numbers as unpredictable in computer programs. So because everything has a source code, with the routine, we can just get back whatever it is. So we can predict that number that we are going to get each time. So there is nothing random about them. So we can call, to emphasize this, we can call the algorithms as pseudo random numbers, random number generators. And the random numbers can be called as pseudo random numbers. Because if something goes wrong and we need to debug the program, we need to get the exact same random numbers which we use while compiling the program. So we cannot have a different number. So we need to get back the same random number which was used to create the which was used to run in the first time when it went wrong. So we can make this happen by pseudo random number generator because it produces output in a sequence. So we need to fix a value, something called as seed. What the seed will essentially do is that we will manually set the number. It can be 94 or 49 or some number we can set. For each number we set, it produces a random numbers in a sequence. So the same random number will be utilized in generating the programs. So by manually setting the seed before we start asking for the output, we will get the same sequence of pseudo random numbers each time when we run our program. So this is how random numbers are used in computing. Is it clear? Am I audible?
Yes, ma'am. It's clear, ma'am.
Ma'am, excuse me, ma'am, Shanmuga Priya here.
Yes, ma'am.
Ma'am, this seed, I'm not able to understand.
Did you understand there is nothing unpredictable in computer programs? Everything can be retrieved. So
yes.
That is clear, ma'am?
Yes, yes.
So what is called as a seed is that in the program, we will set a value. This value can be anything. 94, 47, 69, something. We will set on value. For each value, it will generate a set of random numbers. For example, 9, 49, something like that. So every time in the program, when we fix the number, the same random number will be generated. If you are not fixing a seed, then every time a different random number will be generated. We will not be able to debug our program. So for our program, the set of same random numbers will be given if you fix the seed. So for every particular seed, there will be a sequence of random numbers.
Okay. So
Is
here
it clear,
in this
ma'am?
example, in this example, 94 is one seed. 49 is another
94
seed.
is one seed. 49
Okay.
is another seed. For each
Okay.
set of seed, we will have a set of random numbers. So we cannot remember all the random numbers. So we will remember the seed. Suppose we are performing on program now, and after 1 year we are going to perform. We don't have to remember all the random numbers to check. So we will just remember the seed so that it will generate the random numbers according to the sequence.
Okay, thank you.
Okay. So next we will see what is called as distribution. So we will look at some of the popular distributions that are frequently used to generate these random numbers, which is used in machine learning algorithms. We will see some of the distributions now. So first we will see uniform distribution. So uniform distribution is one that between the values of 0 and 1, its value is 1. Rest of the places, its value is 0. This is how uniform distribution is formed. So it has two properties. One property is that it is flat and constant between 0 and 1. It takes the value of 1. And the second property is that every value in the range of 0 to 1 is equally probable. The probability of getting any value between the range is equally probable. So suppose if you are getting 2.5 or 0.25 or 0.33 or 0.79, everything has the same probability of getting. So this figure, if you see between the range 0 to 1, it has a constant value. So in computer programs, we don't have to set the start and the end value. We can set any starting and ending value. It is not necessary. The starting value should be always 0 and 1. It could be any starting or ending value. Between that, the value is going to be flat or constant or uniform. The usual, the most popular choice after the default -1 to 1, the value will be uniform. Is it clear? Uniform distribution is a basic distribution where the distribution is going to be 0 everywhere except between 0 and 1 where the value is going to be 1. It has two properties. One property is that we can get only the values, what is it? 1 between 0 and 1, and every value within the range of 0 and 1 is equally probable. Is it clear? Next, we will see what is a normal distribution. A normal distribution is otherwise called as a Gaussian distribution or a bell curve. So unlike a uniform distribution, it has smooth ends. It doesn't have a sharp corners or an abrupt end. It has a smooth curvature. This is the shape of a canonical normal distribution. If you look at normal distribution, it has an enormous variety of real world examples from biology to weather. Many of the samples are normally distributed. Normal distribution is defined by two numbers. One is called as a mean, another one is called as the standard deviation. Mean is the location of the middle of the bump. So mean tells us where is our center location. This is our mean. Mean is also equal to median and mode in normal distribution. So the standard deviation shows the width of the bump. The standard deviation shows how much horizontal stretching or compression the shape has. Usually the standard deviation is represented by the Greek letter sigma. So the area under the curve, about percent of the total area under the curve, covers the first distribution. About 95% of the area under the curve covers the second distribution. About 99.7% covers the area under the curve for the third distribution. This is called as 3 sigma rule or 68, 95, 99.7 rule. We can understand this in a better way. Suppose we have to draw 1,000 samples from any normal distribution. About 680 of them will be no more than first standard deviation. It is between the range minus sigma to plus sigma. About 950 of them are within the two standard deviations. Above 997 of them are within the third standard deviation. So this is how we can understand the standard deviation. So here standard deviation tells us how much spread each curve is. Mean tells us where is the center of the curves. So the larger the standard deviation, broader is our curve. So there is another term called variance. Variance is nothing but square of standard deviation. So normal distribution usually appears frequently because it naturally describes many real world statistics. So many real world statistics follows normal distribution. Is normal distribution clear? Normal distribution is otherwise called as Gaussian distribution.
Yes, ma'am.
Any doubt? Anything is unclear? Is it clear?
Yes, ma'am.
Okay, thanks. So normal distribution is called as a Gaussian distribution. Normal distribution is defined by two parameters. One is the mean and the other one is the standard deviation. Mean tells us where is the center of the curve. Standard deviation tells us how much is the curve is spread. So it describes the width of the curve. So is it clear? And we have the 3 sigma rule where we can find out how much is the standard deviation for the first, second, and the third standard deviation. So next, we will see what is Bernoulli distribution. Bernoulli distribution returns just two possible values. One is 0 and the other one is 1. The example for Bernoulli distribution is that tossing a coin. While tossing a coin, we get only two probabilities. One is head, other one is tail. So the Bernoulli distribution takes only two possible outcomes. So we can, the mean of the Bernoulli distribution can be given as P. So the probability of getting success is P and failure is 1 minus P, because the total summation of a probability of both success and failure should be equal to 1. So the probability of success can be given as P. The probability of failure can be given as 1 minus P. So Bernoulli distribution is again a discrete probability distribution. For a random variable, it takes only two possible outcomes, either 1 or 0. It is the simplest form of probability distribution. Is it clear? It takes only two possible values, either 0 or 1. The mean of the Bernoulli distribution is P. The probability of success is, if it is given as P, the probability of failure will be given as 1 minus P. Next, we will see what is multi-novi distribution. Multi-novi distribution is that Bernoulli distribution takes only two possible outcomes, success or failure. But suppose if you have a 20-sided die. So if we have a 20-sided dice, we will get 20 possible outcomes. So we have multiple outcomes. So when we have multiple outcomes, how we will say a multiple Bernoulli distribution? So the multiple Bernoulli distribution, these two words are smashed and it is called as multi-novi distribution. Is it clear? Bernoulli distribution has only two possible outcomes. If it has multiple outcomes, it is called as multi-novi distribution. So all these distributions are shown to show that how our random variables can be distributed in when it is used in machine learning algorithms. These are the commonly used distribution: uniform distribution, Gaussian distribution, Bernoulli distribution, multi-novi distribution. These are the ones which are commonly used. Is it clear?
Yes, ma'am.
Okay. So now let us look at some what is probability? Anyone would like to tell?
Ma'am, a chance of that event occurring.
Okay, a chance of an event occurring. Even in basic terms, any simpler definition. It will tell us how much it describes that how much confidence we have in our data. It tells us how much trust we can put in our conclusions with which our systems producing. So it is essentially tells us how much confidence we have in our data or in some conclusion which is derived from the system. So as you said, what is the chance of something to happen? We can say how likely something is to happen. It is a set of tools that let us decide that how likely something is to happen. So 0% is it cannot happen at all. 100% is it's a sure thing to happen. We can also use the probability to express the confidence. Suppose 80% probability is that 80% sure that it's this piece of fruit is ripe, or certain team will win the game. 80% sure, 80% confidence is there in winning. So probability is usually between 0 and 0 to 1. So probability of 1 refers 100%. Probability of 0.75 is 75% confidence. Suppose imagine we have a wall. We are throwing an arrow at a wall. So what is the probability that this arrow will hit the wall? It is 100%. It is going to hit in any of this one place. Hitting the wall anywhere is given by the equal probability. If anywhere it touches, it has an equal probability of hitting here or hitting here. So the probability of hitting the wall is going to be the same everywhere. Suppose imagine that if I draw a red circle within the wall, the area of the wall is 2 square meter. The area of the red circle is 1 square meter. What is the probability that this arrow will go and hit the red circle? It is going to be area of the circle divided by area of the squared wall. So that is the probability of the arrow hitting the circle is going to be 0.5. Because the area of this one is 1, this one is 2. So suppose if you have a larger circle, then the even more higher. So if you say probability of A, it means that probability of the event A happening. So here we saw the area of the circle related to the area of the wall is a chance that the event A will happen. So probability of A is nothing but the area of the circle divided by the area of the wall. So the probability that when throwing a arrow will hit a circle, then the rest of the wall is probability of A. What is the probability that the that this arrow will hit the circle, then the rest of the wall? So probability of A is nothing but a simple probability. Sometimes we can call this as marginal probability. Did you understand what is probability?
Yes,
Next
ma'am.
Next we will see what is conditional probability. So far we are looking at the probability of an event happening. So suppose if you have 2 events. So one event is finished, one event should happen. Let's take an example. Suppose there is an example saying that a person is thirsty and a person is drinking water. So what is the probability that someone is thirsty given that they are drinking water? It is that 2 events, not just one. Either one of the event might happen. So the conditional probability is given as probability of A given B. In that, what is the probability of A given that the probability of this event is already happened? B is already happened. Having said that B is already happened, what is the probability of A? One event has already happened. We wanted to know what is the probability of the other. We can write, like, suppose for example, we can write A is being thirsty. If A is true, which means that the person is thirsty. If A is false, the person is not thirsty. B is drinking water. If B is true, then we can say they are drinking water. If B is false, which means that they are not drinking water. These two events not necessary, they have to be contingent. Some can, what to say, it is not necessary only when we are thirsty we are drinking water. Even to swallow a pill, we can drink water. So it is not, these two events are relatable, but not necessary to be contingent upon each other. So probability of A is nothing but probability that the person is thirsty. Probability of B is probability that the person is drinking water. So conditional probability is probability of A is true given that we already know B is true. So probability of A given B is what is the probability that A is true given that B is already true. So what it can be otherwise also. Probability of B given A. What is the probability of B being true given that A is already true? Is it clear? These two events are related, but they don't have to happen together. So what is the probability of one event being true given that the another event has already happened? It is called as conditional probability. It is giving the condition that one event has already happened. So what is the probability of the other event to happen? So next we will see what is joint probability.
Ma'am, excuse me, ma'am.
Yeah.
Yeah, in the previous one, conditional probability, can we take it as the probability of lung cancer like that in smokers, like that? Given that the smoking has habit is there, so what is the probability of having lung cancer like that? It can
Yes,
be
ma'am,
taken.
we can get. Yes, ma'am.
Okay.
One event has already happened. They are relatable. So they are,
Okay.
when they are smokers, what is the probability? How likely they are to get a cancer?
Ah.
We
So
can be
we are
like that.
fixing one condition and then looking for the probability of the other one.
Yeah, one fact is said already. One is true.
Okay.
One event is true. That is what we are saying. One event is true. What is the thing? That is what we are saying with the thirsty and the drinking water. The person is drinking water. What is the probability that the person is thirsty?
Okay. Okay, ma'am. Thank you.
So it is not necessary that always, if the person is smoking, it is not always necessary that person has to have cancer. It can be false also. It can be true or false. We do not know. The event of having cancer has not happened. But we wanted to know what is how likely they can get a cancer.
Okay.
Yes, ma'am. That example is correct.
Thank you.
So next we will see what is joint probability. In the last section, we have seen that we want to find the probability of one event happening given that another event has already happened. So what if we do not know if both the event has happened yet? So it will be helpful to know what is the probability of both the things happening at once. So joint probability is that both the events has not happened. What is the probability of A and what is the probability of B? Previously, one event was true. We wanted to find if other event was true or not. So now here we want to find both the events. What is the probability the person is thirsty, and what is the probability that the person is drinking water? Both the things we wanted to see. So what is the probability that the person is smoking? What is the probability, how likely he would get cancer? So we want to see both the events. So this is called as a joint probability. This comma can be read as and, probability of A and probability of B. So joint probability of A and probability of B can be given as probability of A given B into probability of A. Sometimes we don't put that multiplication sign. So we write probability of A given B into probability of B. Sorry, the given condition has to be written. It could be other way also. Probability of B given A into probability of A. In joint probability, we would like to know what is the probability of both the things happening at once without already knowing about either one of them before. Is it clear? This is joint probability.
Ma'am,
Yeah,
ma'am, can you repeat joint probability, ma'am? I didn't
sure.
understand.
So lastly, we saw conditional probability means we will have, is conditional probability clear with you?
Yes, ma'am.
So in conditional probability, we have two probabilities. One has already happened. One, we wanted to find it out. So what is the probability of A given that probability of B is already true? So here we have two probabilities. So it is a joint probability. We do not know A is true or B is true. We wanted to know what is the probability that A is true, and we wanted to know what is the probability of B is also true. So we want to find the probability of A and probability of B. So we want to know, in our drinking water example, we wanted to know what is the chance that someone is thirsty and as well as drinking water. Did you understand? Someone is thirsty and drinking water. We want to find the probability of both.
Okay, ma'am. So, ma'am, in
What is
before case we used it two differently. In this, we are using it both together.
both together? So what is the probability of somebody having cancer given that they are, what is the probability of having cancer and smoking? What is the probability of smoking? Both together. There it was given. What is the probability of having cancer given that they are smoking? Here we are seeing what is the probability of having cancer and what is the probability of smoking. So what is the probability of the person is thirsty and also drinking water? So we are seeing two probabilities together.
Okay, ma'am.
Okay, so that
Yes.
can be given by P of A given B into P of B. P of B is a simple marginal probability. This is a conditional probability. The joint probability is given by this formula.
Hello, ma'am.
Yes, ma'am. Yes, sir.
Ma'am, isn't joint probability just multiplication of A for joint probability of A and B? Isn't it should be probability of A into probability of B rather than a conditional probability coming into it?
No, it is not the joint probability of A and B. We want to see how they are related, right?
Okay, ma'am.
So what
Okay.
is the probability of somebody is thirsty given that they are drinking water? And what is the probability of drinking water? So that is how it is written.
Okay, ma'am. Okay. Thank you.
So next we will see about marginal probability. So imagine in an ice cream shop, there are 150 customers per day. So we have two types of flavors. vanilla and chocolate, and it is being served in cup and cone. So there are 150 customers every day. So now we can put in what? So there are 40 customers who are taking vanilla in cone, 60 customers who are taking chocolate in cone. There are 20 customers who are taking vanilla in cup, 30 customers who are taking chocolate in cup. So now we can derive the marginal distributions in each cases. So what is the probability of ice creams selling in cone? So for that, what we will do, last time we saw what is the probability of getting a particular type of car. For that we saw the number of particular type of car divided by the total number of cars. So here we will see how many people are getting ice cream in cone. It is 100, 40 plus 60, 100 divided by the total number of people who are taking ice creams. So 150, this is equal to 0.66. So what is the probability of somebody taking ice cream in a cup? So this is 20 plus 30, 50 divided by 150. That is approximately 0.3. So if you add both the things, either they have to take ice cream in cup or else they have to take an ice cream in cone. So adding these two will give you 1 because either of the one has to be selected. So the total probability of having a probability of ice cream in cone and having a probability of taking in a cup, both the one will add and give it to 1. So similarly, what is the probability of marginal probability of buying a vanilla ice cream? So this is 40 plus 60, either in cup or in cone. It is 60 divided by 150, which is 0.4. So next, what is the probability of buying an ice cream in buying a chocolate ice cream? The 60 plus 30 is 90 divided by 150. So this is 0.6. So even if you add this one will be equal to 1 because either they have to buy a vanilla ice cream or a chocolate ice cream. So this is how we will calculate the marginal probabilities. So suppose if they are not adding to 1, we cannot call them as a probability. Is it clear? Since it is 100% sure, either this one or this one they have to buy. So it is 100% sure. So they will get either one of those. So it is adding to 1. This is how we calculated. So now we will understand what is a confusion matrix. A confusion matrix is it's a matrix between the actual value and the predicted value.
Ma'am?
Yeah.
Ma'am, and before marginal probability, we calculated the probability of cone and probability of count. Ma'am, can we say this is similar to the positive predictive value we calculate for study and the negative predictive value?
Fantastic. This is equal to precision. So what is the true positive divided by the total number of positives? Fantastic. So this is the marginal probability. So here we are dividing it by the total number of, we will come to that positive predictive value later on. But here you understand that what is the probability that individual, suppose what's the probability of buying a cone is people who are buying cone divided by total number of people who are buying an ice cream. That is how we calculate the marginal probability. We don't have to confuse it with confusion matrix now, but for now you can understand marginal probability as it is. So here we will have all those things. So here we have the actual value and the predicted value. So if both the things are positive, we call this true positive. Most of the people will be familiar with it, so I'm just skipping it out. False negative, false positive, and true negative. So accuracy, are everyone familiar with these performance metrics, accuracy, precision, recall? Is everyone familiar with? I'll quickly run through because most of the people would be familiar with it. So accuracy is a value between 0 to 1. It will tell us how often our prediction is going to be correct. So accuracy can be written as true positive plus true negative divided by all the sample values. It's a rough measurement. It will not tell us about how, in what way the predictions are going to be wrong, but will give us a broad feeling that how much time we are getting the right result. So next, we'll take precision. Precision is positive predictive value. So it will tell us the percentage of samples that are properly labeled as positive relative to all the samples that we are labeling as positive. So precision can be given as TP divided by TP plus FP. So true positive to all the labels which have been labeled as positive. So we can say the value of precision is the total number of positive samples that are really positive divided by the total number of samples that are being labeled as positive. Labeled as positive is important. Next, we will see what is recall. Recall can be otherwise called as sensitivity. So it is also called as a hit rate or true positive rate. Recall is given as true positive divided by divided by the total number of samples that should have been labeled as positive. Should have been labeled as positive is an important phrase. So recall value is the total number of correctly labeled positive samples divided by the total number of samples that should have been labeled as positive. Next, we have specificity. So specificity can be given as true negative divided by true negative plus false positive. True negative divided by total number of samples that should have been actually labeled as negative. So another score, F1 score. So F1 score is a combination of both precision and recall. It is useful to have two information together. So F1 score is given by a average called harmonic mean. Harmonic mean is nothing but reciprocal of the average of the reciprocal. So if n entities are there, so it is the reciprocal of average of entities. So if you have x1, x2, x3 up to xn, the reciprocal of its average is harmonic mean. So F1 score is a harmonic mean of both precision and recall. So we have two entities, precision and recall. So I am writing n is to be 2. And we have two entities. So 1 divided by P plus 1 divided by R. So this will be equal to 2PR divided by P plus R. So here in F1 score, if either precision and recall are 0, it is going to be 0. F1 score will be 1 only when P and R is going to be 1. Is it clear? Next, let us see. Everyone are clear with this confusion matrix? So it is a matrix between the actual value and the predicted value. So let us understand how these confusion matrix can get wrong. In what way we have to apply a confusion matrix? We will see with an example. Let us assume in a town there is a imaginary disease called MP. So everyone in the town are tested by two different tests. One is a slow and expensive blood test. and the other one is a faster and a cheaper blood test. So the slow and expensive blood test can be considered as a ground truth. Our measurements show that it has a high true positive rate. So the true positive is about 99%, which means that our false negative is 0.01. Similarly, we have a high true negative rate, which is 0.98% true negative rate. We can write it true negative is 0.98 and false positive is 0.02. And we also have another information that we expect that 1% of the population is already infected. So having this information, it is very tempting to draw a confusion matrix. So we can pop in all those values very easily and we will get a confusion matrix. But this matrix is incomplete, will lead to wrong answers. Why it will lead to wrong answers is that because we are not adding, we are ignoring this information that 1% of the population is infected. So we have to include this information in the confusion matrix. How we will include? So let us assume we have 10,000 people in the town. We have the information that 1% of the people is infected. So 1% of the people who are infected is 1% in 10,000 is 100 people are infected. So we have 99% true positive rate, correct positive. And 1% incorrect negative. So 99% of 100 is 99 true positives. 1% incorrect is 1% as false negative. So when 1% of the people is infected, 99% of the people are not having MP. Here, if you look at the people who have MP and people who don't have MP are same. The true positive rate and the true negative rate are going to be same, which is very difficult to understand because 1% of the infection rate is there. So it is unlikely to happen. So 99% of 10,000 people is 9,900 people. So we have 98% correct negative. 98% of 999 people is 9702 true negative. So now look at it. True positive is only 99. True negative is this much. So there is a difference. But whereas in the previous case, it was equally likely. So now 2% of the population is have incorrect positives. 2% of 999 is 198 false positives. So now with this information, we can have a confusion matrix. So true positive is 99, false negative is 1, false positive is 198, true negative is 9702. So this is a proper confusion matrix of our F-test. Incorporating our knowledge of 1% infection rate, the values are derived from this figure. So if someone gets a positive test result, what is the chance that they really do have MP? It is a conditional probability. Someone gets a positive result. What is the probability? What is given as positive result? So if somebody is having a positive result, what is the probability that they will have MP? So this can be given by precision. So somebody is having positive result that is given. Whether it is true positive or false positive, they are having positive. So somebody is having positive result. What is the probability that they will get a how likely they are to get this disease is precision. So precision can be written as 99 true positive divided by 99 plus 198, which is almost 0.33 or 33%. Similarly, we can write the other metrics. So we can write recall as true positive divided by true positive plus Fn, which is 99 divided by 99 plus Fn is 1. So this will come to 0.99. This is 100, so 0.99. So similarly, we can write specificity, just 2 negative divided by 2 negative plus Fp, that is 9702 divided by 9702 plus 198, which is 0.98. Next, the negative predicted value. Which can be given as 2 negative divided by 2 negative plus false negative, which is 9702. 9702 plus 1, which is 0.99. Is it clear? So far in this class, what we have done is so first we started with randomness. We wanted to see how randomness is incorporated in the algorithm, and also we wanted to review some basic statistics concept. We saw what is random variable. There are two types of random variable: continuous random variable and discrete random variable. We saw the definitions of mean, mode, and median. And we saw what is a probability, what is a probability distribution function. Probability distribution function is two types: probability mass function and probability density function. And we saw how random numbers are used in practice, how it is used in computing. We saw that we got the concept of pseudo random number generators. And we also saw what is seed. And we saw how our random variables are going to be get distributed. We saw some of the commonly used distribution. One is uniform distribution, one is normal distribution. The next one we saw is Bernoulli distribution. Multinovy is an extension of Bernoulli distribution. And then we saw what is probability, what is a simple probability, what is a conditional probability, and we saw what is joint probability and how to calculate marginal probability. Then we saw confusion matrix. And then we looked at various performance metrics called accuracy, precision, recall, and specificity. We also saw what is F1 score. Then we saw how to put a correct confusion matrix. Because what happens is that in the real life situations, we have people are making incorrect decisions or incorrect confusion matrices by having bad questions. We have to incorporate all the information. Just by knowing true positives and false positives, we should not arrive at the confusion matrix. We need to include all the information to get a proper confusion matrix. Because of the, so we have to incorporate all the questions into practice. So we saw how to apply a proper confusion matrices. Is it clear? Is it clear?
Yes, ma'am.
Yeah. Okay, thank you. Monday we will not have a class. I will tell you when we will have the next class.
Okay, ma'am. Thank you, ma'am.
Yeah. Thank you, everyone.
Okay, ma'am. Sure. Thank you, ma'am.